We are looking into what we call towards getting started with ML modeling in any specific field of interest that we might be interested in. I think this is, of course, very, very important point to look into. And it's going to be under our classical important clarification series with the theme Always Let the Data Speak. So irrespective of the area of specialization that we might be working on, for people who are not from computer background, and even if you are computer background, you can also actually use the opportunity of being a professional in this area to benefit many other fields, because the needs keep growing. So, and the demand for people who can support them is also growing at possibly getting to exponential level. So the demand is really very high. And for those professionals in your own area, the least you can do, if you cannot assist others, at least you can take benefit in your own area to see how you can use machine learning and this related concept to benefit yourself and the co-practitioner in your area. So the last 2 weeks or so, we dedicated to describing for us how we can use the recorded videos that we've made available in our YouTube channel, so that because as we keep getting new members, so we welcome everybody and we want to assure you that don't feel you are left behind already. No, you can always meet up. Just get yourself registered in the WhatsApp group, and our admin team, they always send the necessary introductory videos that you can watch. Try to watch those videos. Note down anything that is not clear, and you can ask question in our regular question and answer after a few minutes of a presentation every week. And also you are free to contact us on private levels if there's any specific needs. People have been doing that. So people working on their PhD work, personal research work, and we do find time to clarify it for them, sometimes through WhatsApp voice messages, so that hopefully people can take benefit. So in the last 2 weeks, as we mentioned, we presented the watch list guides for Asomaya YouTube channel, part 1 and part 2, with the question and answer also, whereby we describe in detail the effort that has been put there, so that when you because getting to the YouTube channel and realizing that you have like over 140 something videos might be confusing. Where am I going to start? So just check out this particular video with this title, and then try to see how you can go about it, which one you can watch. And also the good news, also the material itself is already made available in our chat group, so that you can search for what you need. So as a starter, you start from the basic introduction, the revision videos there. As they advance, then you can look, especially we have researchers corner, where you can be able to check out the needed videos that might benefit you, so that you can move faster and be able to deploy the system in your own area of application. So as the topic for today goes, so we are tagging it to how can we get started with it? Have been working in this area. Can I change to another area of application? You can definitely select any area you like. For example, there are so many successful applications of machine learning. So you can check our earlier videos. We have described them. There are videos on successful application of machine learning. We have described several examples and also even demonstrated some of our published work and how we can take hopefully inspiration from it. From today, we want to see, okay, which specific area are you interested in, and how can you then try to deploy or use machine learning to solve your problem in that area. You can see started on speech recognition, computer vision, biosurveillance, mention it, so many of them. Empirical science, most engineering research work, science research work will fall under empirical science. Anywhere you can generate data, just the data. So, and that's why if you see the sub-theme of our present presentation, we call it Always Let the Data Speak. Once you have data set, you can always Think of your favorite area. So how you're going to do it is not a problem. This is what we want to look into. The application list continues. So there's so many of them. According to your imagination, check out what has been done and what is being done. But what we want to use here today is that something that is unique that we need to pay attention to is this. Yeah. And that is that application is generic. Sorry, the applications are diverse. You can see applications are diverse, but methods are generic. So it means the same method you use in solving one problem, you can also deploy it in another problem. That is why getting to know it to solve a problem, that is the only thing you just need to do. Once you are able to use it to solve a problem in a particular area, then you are done. You can always use it for other problem area you want to solve. Because there's any application area, they're going to follow the same procedure or the same steps as the case may be. So this is the point that is very important that I feel we all need to pay attention to, or as the case may be, so that we look at it critically and then be able to see that, okay, which application area am I targeting? Irrespective of your application area, they're so diverse, the method are generic. Once you solve a problem, then you can always solve other problems. It means it works. It's for you to invest in, try to understand how it works. And once you understand how it works, then you can continuously use it in your different area of interest and application area that you might be interested in. And you can even start solving problems for people. Now, so since we say it is diverse, I mean, the applications are diverse, so many areas. Why the method is generic? This is the generic method. We always show ourselves. See, you start from the data. We have data collection, data preparation. So feature engineering. So we've explained some of this concept earlier. Then you go to modeling. This is where you're going to select the machine learning algorithm. Then you're going to check the performance measure. So sometimes you may need to go back. That's the unique characteristic of this method. You can always go back. You don't need to get it right at once. Go back again, do your parameter optimization, parameter tuning, and then do it again. Sometimes you might have to change the algorithm. Maybe it's not working for you. You might have to change it to use another one. Sometimes you might have to go back totally to the data set itself. Maybe to change the features, modify the feature, do feature transformation, generate new features from one feature. For example, you have a date feature. You have a feature that has date, 22/1/2024. You can break it down to day as a new feature, day, the day that the incident happened. Second one is going to be month of the year, see month number 2, number 3, and then the last one is going to be the year. So you can actually form multiple features from one feature. That is under feature engineering. And sometimes you might have to actually go back again and do a lot of pre-processing and the likes, which we've mentioned some of them before, and we are going to continue to discuss them. So then you keep going back and forth until you achieve, because the essence of going back is to achieve performance improvement. Sometimes you might do something that you think is going to improve the performance. It might make it worse. That is okay. You have to go back again, undo, and then continue the procedure again. So you keep doing that until the model reaches a satisfying performance according to your own targets or expectation of your work. Now, this is the generic process that we are talking about, that the applications are diverse, so many, but the method are generic, the same method. And this is a summary of it. So in the model building, you are going to have training the model and then testing the model. And then after that, put up together these simple steps that we can say, I call it important step for getting started with ML modeling in any specific field. So in any area you want, the first thing is for you to first of all identify your area of interest. Where do you want to work? Identify it. basically any area you are interested in, for sure, you're good. It's if data can be gotten there. And the good news is even you can get data from even interview. If data set is not available, you can create data yourself. So identify your area of interest for. This is very important step. Once you identify the area of interest, then the next thing is to start looking up. Look for free online data set to start with. Check out free online data set that you can actually start with. This is very important. Don't wait until you get your own data because that could take time. See, and some of these online data set are really very, very good data that will put you on the track. And once you understand the way it works, then you now go back to your own, try to get your own data set maybe. So build your first model, first machine learning based model using the free online data set. This is the way to go. So you have to do what we call hyperparameter tuning. That is to tune the algorithm. See, this is what we alluded to here. You might have to go back here. Maybe you are using k-nearest neighbor, you have to change the parameter of the algorithm to see 1 is not working, maybe 3 will work, maybe 5 will work, until you get the one that is working. And sometimes nothing will work for that algorithm, then you might change the algorithm itself to another one, to decision tree. And then you keep doing that. So, and sometimes you might have to use sophisticated algorithm, like support vector machine, or even go to what we call Mushakel, that is ensemble, mix them together, combine multiple algorithms to get better result. You keep doing that and coming back. So this is what we call the tuning of the hyperparameter of the algorithm. So, and sometimes you might need to select better algorithms. That is the one you are having is just not working for that problem. Because based on the principle of let the data speak, you cannot really say which algorithm will work for you. You can see I mentioned here that this is compulsory. You have to do hyperparameter optimization. This is compulsory. It's not optional. Oh, I run the results, and the first one I ran, the default parameters gave me good result. Yeah, that is not still enough. For example, in machine learning experiment, you usually have at least 2 algorithms to compare your work with. So you run the first experiment using algorithm number 1 or A, and you're able to get maybe 99% accuracy, excellent work, or even 100, everything perfect. That algorithm was able to recognize your data set using the default parameters. And then you record that, and then you select the second algorithm B, and then that one was getting maybe 70%. You don't go ahead and conclude and say the whole algorithm A is better than B. No, you have to do parameter optimization for each of them. Default parameter may be the best for one, but you still have to give the second one the opportunity also to demonstrate its own capability. Otherwise, your report is not going to be valid. So that's why I said hyperparameter optimization or tuning is compulsory. It's not if I like. No. If it is missing, if you write a paper there's no hyperparameter optimization, if it is a good journal where they are really reviewing, that's the first thing that will catch the attention of the reviewer will be directed at. No, this is not acceptable. Because when you submit a report, somebody must be able to sit down and reproduce your work to know how you got that result. So you have to tell them the hyperparameter value you use. They just need to open a machine learning platform and enter the application, open the algorithm, enter the hyperparameter value you specify, and then if you release your data is publicly available, they should be able to get your result. Even though not many people have the time to go and do that, but they want to see that your procedure, you have followed the procedure. So we have to take note of that this is compulsory. You have to run the hyperparameter optimization or tuning, that is looking for the value of the hyperparameter that is going to work for you. Do other pre-processing like normalization. Sometimes we normalize data. It's a common concept. If the range of the data is huge, we want to normalize them so that everything falls into the same range. Resolving data imbalance, feature selections, you can say, these are optional. Optional in the sense that they are not compulsory, things you have to do. See, a lot of people, we'll come back to this later on, we'll talk about it in detail. Some people take it like they have a pipeline. They set a standard they have to follow. Once they get the data, they normalize, they resolve imbalance, do feature selection. No, it is wrong. You see, these are optional stuff. It's always good for you to let the data speak. See, that is the title here. Let the data speak. It always have to hold. Run the experiment on the original data set, see what you are getting. Then if it's not getting better after you have done optimization, which is compulsory, it's not optional. This one is not optional. You have to do it. However, normalization, then you can come back to it. After doing all these compulsory stuff, yet your data is not able to communicate with the algorithm, or the algorithm is not able to understand your data set, then you have to start looking for other pre-processing stuff you might have to do, like normalization. The data is imbalanced. It is natural for data to be imbalanced. We are going to talk about this specifically. I've seen a lot of people making mistakes in this respect. Resolving data imbalance is very important, but you don't do it immediately because imbalanced data is a natural characteristic of the world. For example, in a normal society, the number of sick people should be lesser than the number of people that are healthy. So when you get data set where the samples for the sick is lower than the healthy people, this is normal distribution of a normal population. A population where the number of sick person is equal to the number of healthy person is abnormal community. So when we want our data to be as natural as possible, so that's why we have to avoid too much preprocessing that might lead to mutilation of the data set. So once you are done with that, that's why I say this is optional. Then you analyze and discuss your result. Analyze the results. Knowing how to analyze results is very important. So each of these, we're going to pick them later on, one after the other, and we're going to give us examples of how we can do that. Then document your experimental outcomes and findings, and then disseminate your result in case of interesting findings or improvement. Sometimes the online data sets that some people think is not useful, you might actually, if you're a research-oriented person, you might actually publish it. A lot of work has been published using freely available data set, either because the people work on it before, they had limitation in their performance, you can improve the performance. Sometimes they have not used some unique method that needed to be demonstrated for people on how to do that. You can also get into it. So we can check out our earlier video, which we call gap identification. That's a video on how to identify gaps in research. When you pick up a machine learning based research, when you look at the abstract, you should be able to construct a new design of experiment you need to carry out, because you can easily be able to see, oh, these are the gaps this is what they have done, read the experimental description and discussion of result, then you can be able to understand what is missing. If you're able to fix or fill any of those identified gaps, why not? You can document your work and disseminate appropriately in conference, in journal, depending on the problem and the area you are. Now, moving further, after you have done that, at least that will give you the understanding of having an idea of what is obtainable in your area. Now, based on the experience from the online data set, you now try to gather new data set related to the area of interest. You try to gather new area. You have to gather new data set related to this area of interest. Gathering this data means you have to contact interested parties or relevant establishments requesting for the intended new data set. See, sometimes you have to provide them with the needed attributes. What are the attributes that they need to provide? What are the characteristics they should generate for you? But sometimes don't limit it, because based on your professional knowledge, you think so attribute is better. They might not actually be the one that will work for you. So what I usually advise is that tell them to provide you with all available data set that they can lay their hand on. Of course, sometimes they say, oh, it's going to be too much for us. If they have it in their system already, let's say you have a hospital that has medical records. Usually they ask you to go to medical doctor to tell you what are the attributes about diabetes that you should look for. No, let them give you whatever information they have about those patients. If they can agree with you, this is the best way. Because sometimes some of the old practices, or the particular characteristic that they look into in patients to diagnose them, some of them are getting obsolete. But human beings are not aware because things are changing. The kind of food we are eating is different from what we used to eat before. So a lot of things have changed in the body of human being. This day you see a child of maybe 10 years is maybe bigger than somebody of 20 years. So a lot of things have changed, and you still want to use the same yardstick to diagnose them. So that's one of the essence of machine learning in this age. It's able to give us all the attributes, both the one that the professionals or the specialists regarded as compulsory or important, and those they thought they are not important. Get everything. During what we call feature selection, you can see here feature selection, we're going to identify those features that are most worthy of being used in your application area. So you have to wait for them sometime. Getting the data is very challenging. We have seen people falling off with data set for 1 year, and the research is time bound. You have to be aware of that. So that's why you actually encourage people. If you are not sure of getting data set in an area, don't dabble into it, except you are ready to get the data through interview or questionnaire. This is another very simple way of getting your data set. Because without data set, you cannot proceed. It is all about letting the data speak. So if there's no data set, then you cannot do the modeling. So before you proceed on an area, either you have gotten online data. I usually tell people to work on this area, make sure you have secured an online data set, especially undergraduates. Whenever they're working on their data set, usually I tell them that, okay, just try to pay attention to getting online data set first in any topic you are going to select. So in case you cannot get your data set for the official one, you are on the safer side. At least you can do something and graduate as an undergraduate. You don't need to, it's just ordinary project. But for the thesis work, then you might have to do a lot of work, get your own data, the time is there for you through interview. Often I've seen that a lot of people do ignore this option. Just looking for data set, waiting for years, and then after the day, okay, I need to change my topic. Changing the topic might not be the solution. Why don't you think of using interview or questionnaire means to get data set from people? Especially in this day that you can broadcast, build a small Google form, broadcast it to people, and let them respond. And you can get data that will become useful to other people in future. You can even share it later. There's some website you can publish your data set. It will be useful for other generations to come. And that's good to also be an opportunity for you. You can ask them also to cite your work where this data set has been initially presented. So once you're able to do that, then do the new modeling using the new data set. Then you have to carry out the same approach we have analyzed before. You have to carry it out on the new data set, analyze it, document it, discuss your result, and then disseminate your findings and outcome accordingly. So these are the procedures from which we are going to be taking some of the very important aspects of it that need clarification as we proceed. We'll be taking one after the other, and then we'll be analyzing it for access, inshallah, as the case may be. So this is the generic procedure. Start, get your data, pre-process the data, build your model, and then test your model. If it's not okay, you go back and modify it until it's okay. Validate your model, predict new cases on same data set, analyze your result, and identification of hot spots. That is, identify future work. Because as you are carrying out the machine learning based modeling, a lot of ideas will be coming to your head. Can I do this? Can I do this? You cannot always do everything, otherwise you will never finish. So what I usually recommend is, as the ideas are coming in, keep documenting them. These are possible future works that you can even put in your report, in your paper, for people to benefit. Of course, some people, if I put it there, people will do it before I do it. Once you start practicing this in this field, a lot of ideas will be coming to you that will be too much for you to actually implement. So let others also benefit from your knowledge. So future work recommendation, put them there. It's good for your student, for people who read your paper to have an idea. Oh, these are some of the ideas along the way. We call them fence out in research, fence in and fence out. Fence in and those new ideas that came along the way of doing your research, you included it in your work. But some cannot be included because there's no time. So in that case, you can make them as future work recommendation as the case may be. So these are the procedures that are very, very important for us to be able to implement our machine learning modeling in our own unique way that we have actually selected. And let's not forget, yeah, so it's going to be part of it. Identify your area of interest. It's very important. I'll be having a small presentation of machine learning in crop production. So how can we increase the yield so that we can provide food on the table of our fellow, of our own self, our family, and our fellow countrymen and worldwide? What can we do? So how can machine learning actually assist us in this area? This was based on one of the questions from one of our participants. But considering the importance of food in our life as human beings, so I've offered to provide some of the areas that people in those areas can be. And also when we have time, we can also touch other areas of specialization like material science and polymer technologies, and how can machine learning be utilized in each and every one of these. Thank you very much for listening.